Hey guys, welcome into our first video presentation of our AP Summer Calculus assignments. I'm glad to have you with us. What we're going to do here in section 1.1 is some very basic review of stuff that I know that you already know. But things that we're going to see here in section 1, our learning goals are using increments to calculate slopes, writing the equation and sketching a graph of an equation given some different information. We're going to identify relationships between parallel and perpendicular lines and their slopes. And lastly, we're going to use our calculator to generate some linear regression models in order to solve some problems. Okay, let's get started. Okay, increments define slope. Delta, as I'm sure you know, is a Greek letter. It looks like that little triangle symbol, and it's used to represent a change in quantities. So if we talk about delta x, that means the change in the x values, or x2 minus x1. And very similarly, delta y, of course, is the change in the y values, y2 minus y1. And remember, these x1s, y1s, x2s, xy2s come from the coordinates of the 2 points that we're using to calculate the slope of our line. So that would mean, of course, as you all remember, slope of a line is the change in y over change in x. So y2 minus y1 over x2 minus x1. Okay, also a quick reminder for you, vertical and horizontal lines. A vertical line, slope is undefined, and the equation of a vertical line is x equals some x value, whatever x-intercept that line happens to pass through on the coordinate plane. And similarly, horizontal lines, remember their slopes are always a 0, and their equations are y equals whatever y coordinate that line happens to pass through on the y-axis. Next, we have our linear trinity. These are the different forms of our linear equations. So first, we're going to talk about point-slope form. We're actually going to use this a lot here in section 1.1, which is y minus the y1 coordinate is equal to the slope times the quantity of x minus the x1 coordinate. Slope-intercept form, y is equal to mx plus b. And lastly, probably the least common, is the standard form, which is sometimes called general form, which we see as ax plus by is equal to c, where a, b, and c are all integer values. Okay, here's the first big thing you need to remember. Slopes of parallel lines are always exactly the same. And then our second rule for perpendiculars, product of the slope is -1. Sometimes we call that opposite reciprocals, for example, 2/3 and -3/2. But whenever you multiply the slopes of perpendicular lines, assuming, of course, we're not talking about a horizontal line and a vertical line, because that vertical line has no slope, we can't say that it's going to give you a product of -1. But all other pairs of perpendicular lines, the product of their slope is going to be -1. Okay, and the last piece of this, which I'm not sure how much of this you did in pre-calc, I know certainly using our new technology is going to be new to you. Regression analysis, it's when we fit a curve to a group of data points, and that curve is called the regression curve. And what we're going to see mainly in this section is we're going to have some scatter plots. And you can see that red line, we call that the line of best fit a lot of times. When we actually generate the equation for that line of best fit, it's called the regression line. And using our fancy TI Inspires, this is how we're going to do it. So take a moment, pause the video here. If you don't have your Inspire out, go ahead and pause, get that out, get it turned on, and then hit play again so you can follow along with the steps of how we're going to do this. Okay, this is actually an example. This is from table 1.1, which is on page 7 of your textbook. And this is how we are going to put this data table of information into your Inspire, and then based on this data table, we're going to be able to calculate our regression line. So I need to quick escape from my PowerPoint here and pop up my software that I have that matches your Inspire. So the first thing you're going to need to do, you're probably already on this home screen. If you're not, hit the home button so you have all of these options. And use these arrow keys here to arrow yourself around to get to, we need a new spreadsheet, which is sort of right there in the middle. and that's what we want. So we're going to click on that spreadsheet. Okay, the first thing we need to do is we need to name our lists. So arrow yourself up to the top of the A list, and we're going to replace that with X. It doesn't have to be X, but it just makes a lot of sense because this is going to be the values on our X-axis. And then similarly, we're going to label the B column with Y because these are going to be our Y values. Okay, now that we've labeled each column, I want you to take a couple of moments and we're going to enter that information in from the data table, and I'm just going to scoot mine over here so I can read my data table. And I'm going to take a couple of moments and just enter in my X numbers, which represents the years, and then my Y values, which represents the population. So go ahead, as I enter these things in, you can do this. Okay, now I've entered my years and my populations in my X and Y lists. So we're going to move on with the process here. So next thing I need you to do is we're going to arrow over and get ourselves into the first box of the C column. We just need to make sure that we're out of our X list or our Y list to do this. And this is what we're going to do to actually get our regression equation. So let me scoot this over in the middle so you can see a little bit better what I'm doing. Okay, so now that we're over here in our C list, we are going to Menu and Statistics and Stat Calculations. And once you're in Stat Calculations, you have all of these different types of regressions we can do. We want to do a linear regression, and number 3 is in slope-intercept form, which is what we're looking for. So we're going to select that. We need to now put in our X list and our Y list, and our X list we conveniently named X, and our Y list we named Y. So enter X and Y there. These other pieces of data are not important for what we're doing, so we're just going to leave those as they are and click OK. And you'll see what pops up here now over here in the E column is our information for a regression equation. The slope is 79.9572 and the y-intercept is negative 153,849. So take a minute and jot that regression equation down in your notebooks, please. Y is equal to in mx plus b form. And once you have that written down, what we're going to do is we're going to actually build the scatter plot of our data points. So to do that, I'm going to go over here back to the calculator and I'm going to hit the home button because I need a graph, and you can arrow around until you get yourself to the graph document, and it's the blue one there with the parabola. So we're going to click on that and enter, and that's going to bring us up a nice graph screen. This is a coordinate plane though, and we want our scatter plot, so we're not going to be entering a function, an f of x function. We're going to be putting in our scatter plot. So let's go up here to Menu. Excuse me. You're looking for the option that's going to allow you to choose the type of graph. Mine says graph entry / edit. I believe yours might say graph type. I'm not sure that yours matches exactly mine, but you're looking for the option that you can choose the type of graph that you want. And we do not want a function. We want to go down and to find the scatter plot option. So here's our scatter plot graph. First they're asking us for our X list and our Y list. So we're going to put X for the X's and Y for the Y's, also why I chose to name them that, and go ahead and hit enter. And when you do that, up pops our Cartesian equation, or our Cartesian plane again, with what appears to be nothing in it. But if you think back to the numbers in our data table, they do not fit within these constraints of X and Y. They were years, they were up into the thousands, as were our population numbers. So we need to zoom out so we can actually see those. So I'm going to go to my menu option, and I'm going to go to my zoom, and I am going to do zoom fit so that I don't have to guess where it's going to be. It's going to take me exactly there. So once we do zoom fit, there are all of our data points. So we can see the scatter plot from our data. And then the last thing we want to do is we want to get our line of best fit in there, or our regression line. And we want to see how closely does our regression line actually fit our data points. So to do that, again, I'm going to go over to my menu because I want to enter a new graph. and I'm going to go here, and the graph I want to enter this time is a function, because this is going to be our regression equation in terms of y equals or f of x equals. And you'll notice this says f2 of x equals. Actually, what very conveniently your calculator has done is it has already stored that regression equation as the first function. So this is f2. To get to f1, you're going to go over here, you're going to click the tab, and then the up arrow will take you up to the first function, which has already been stored for you, and that should look very familiar. That's our regression information. The slope, of course, we sort of rounded and truncated off here, but this has the much larger value, the much longer expanded decimal, which is perfectly fine. So once we have that in there, we're going to go ahead and hit enter. And there you go. You can see your regression equation, the graph of that pop right up on top of our scatter plot. And you can see it does fit very, very nicely. These data points happen to line up very linearly, so that shouldn't really be too much of a surprise. So that's how you create a regression equation, how you graph the scatter plot from the data points from the table, and then you go ahead and you graph your regression line on top of it to check to see how closely it fits. Okay, we're sort of done with the calculator now, so I'm going to get rid of that. Oh, nope, I don't really need to save. Let me get rid of that. No. Alright, let me go back to my PowerPoint. So here are all the steps that we followed, getting us this regression equation. We're now going to take that regression equation and we're going to do some predicting with it. So we are going to predict what is the population in the year 2010. So there's our regression equation. Our x value, of course, is the years. So we're just going to replace x with 2010. We're going to do our calculations, and we're going to get approximately 6,865. Remember, from the data table, those were millions, so 6,865 million people is the predicted population from our regression equation in the year 2010. Okay, that wraps up the information in section 1.1, except for maybe that regression stuff. I don't think any of it should be new or surprising to you. So for your practice, I'd like you to read through examples 1 through 7 on pages 1 to 6 of your textbook. And this is a list of the homework problems. Please keep a separate homework notebook from your regular notebook so that we have two different places. You have your notes simply in one place and all of your homework problems in another place. And again, I will be checking for this when you get back to school, so please make sure you have it readily available. So pages 9 and 10, questions 1, 9, 13, 17, 27, 31, 35, and 45. If you need any help or you just want to check in with me, my email is on the sheet that I gave you. It's Pauly, P-A-U-L-Y-M, at brsd.org. Feel free to drop me a line, ask me a question, just check in and say, hey, let me know how your progress is going, whatever. But that wraps up section 1.1, and I will see you back at section 1.2.